Exercise 14.3, page 158, number 5. Which of the following statements are true with regard to a circle? The area is always numerical larger than the circumference. Okay, so let's first get our formulas in place. So we know the area of a circle is pi radius squared, whereas the circumference is 2 pi radius. Now, if the area of a circle is always larger than the circumference, it means the ratio of the area to the circumference has to be larger than 1. So we can get the ratio of the two. So we can take the area divided by the circumference, and if the area is bigger than the circumference, the answer should always be bigger than 1. So therefore, if the area of pi radius squared divided by the circumference of 2 pi radius is greater than 1, then in fact the area will be larger than the circumference. So now we can simplify a bit. Well, let's just finish our statement. So if that's the case, then the area is larger than the circumference. So let's simplify a bit. So we can see that we have a r and a r. So we can cancel the one radius with the other. So we have a radius at the top. The 2 pi's we can cancel. So we actually now have r over 2. If r over 2 is greater than 1, then the area will be bigger than the circumference. So now we are simply interested in r, so we can actually multiply the left and the right by 2, so that we can cancel the 2. So we say as soon as the radius is greater than 2, then the area will be in fact bigger than the circumference. So now to get back to our statement, the area is always numerical larger than the circumference. This is not true because we can see the area will only be larger than the circumference if the radius is in fact larger than 2. Let's test this. Let's say the radius is 3. Then we have here 3 squared, which is 9 times pi. So the area is 9 times pi. Let's substitute 3 in the radius for the circumference. So now we have 2 pi times 3. 2 times 3 is 6, so it's 6 pi. So we can see it's in fact the case that 9 pi is greater than 6 pi. So a radius of 3 which is greater than 2 will give an area larger than the circumference. Now let's take something smaller than 2. Let's use 1. Let's say the radius is 1. Now the opposite should result. Let's test. Okay, so this was when the radius was 2. Let's test now if the radius is 1. So we have 1 squared times pi, which is simply pi. Let's look at the circumference. We have 1 times 2 pi, which is 2 pi. And now we can see the area is in fact smaller than the circumference. So therefore we definitely know this statement A is false. We just have shown that it is false. So let's move on to statement B. The area and circumference are never numerical equal. Well, let's see. We said if r is greater than 2, the area is larger than the circumference. If r is smaller than 2, then the area will be smaller than the circumference. What about if the radius is equal to 2? Let's test that scenario. So, if the radius is equal to 2, we actually showed here the radius is equal to 3, not 2. So if the radius is 2, let's see what our results will be. So we have 2 squared, which is 4, so we have an area of 4 pi. Whereas, if we replace the radius for the circumference with 2, we have 2 times 2, which is also 4 pi. So, in fact, there is a scenario where the area is exactly the same size as the circumference, and that is when the radius is exactly equal to 2. So this statement is therefore also false. The area and circumference are never numerical equal. That's false. We just shown it's true if the radius is 2. Number C. The area is sometimes numerical larger than the circumference. Well, we already have shown it. We already have shown that if the radius is bigger than 2, the area will in fact be numerical larger than the circumference. So that statement is true. It is sometimes the case. Number D. When the circumference of a circle doubles, then the area also doubles. Okay, so let's look at the circumference. So basically if the circumference doubles, so the circumference now has to be 2 times. So if we have a radius of 2 times what it currently is, then the circumference will become, okay, so let's just do this. We have the circumference of the old, which is 2 pi radius. Let's test it against the circumference of new, which is now 2 times the circumference of the old. So it is 2 times whatever the circumference of the old was, which is 2 pi radius. So the new circumference, if we double, is 4 pi radius. Okay. Now let's see if the area will also double. So if the circumference double, does the area also double? Okay, so for area, the area of the old we know is simply pi radius squared. So now let's look at the new area. Okay, so now for the new area, we could actually in fact say this 4 pi radius is so we can actually just say all that now change. Instead of having a radius, we in fact have 2 times the radius. So we can say the area is pi, the new area, but the radius is now in fact not radius, but 2 radius. So we still have to square 2 radius. So we have now pi, 2 times 2 is 4. Remember, we can separate when we are multiplying in brackets. So we have the 2 squared multiplied by r squared. So we now have in fact 4 pi radius squared. Okay, so now let's see. Did the area double? No. If we compare the old area to the new area, it is in fact 4 times more. It in fact happens because we are working with square units. For the circumference, we were only working with normal units. So if we double the radius, then the circumference will double. But now, if for the area, since we work with square units, if we double the radius, then the area will in fact be 2 squared times, namely 4 times larger. So this statement is false. The area don't double, it's in fact 4 times larger. Finally, let's look at E. The circumference is always numerical larger than the area. We already shown this is not true. It depends if the radius is larger or smaller than 2. So this is also definitely already shown as false.